Hello students, in this unit we are going to discuss land pollution. Now land pollution is a topic which was not a very important topic until last few years, because if you talk about the Air Act or the Water Act, these are the acts, as you would see in the upcoming lectures, that were devised in India a long time back. We understood the effects of air pollution and water pollution long time back, but same was not the case with land pollution. Just take for an example e-wastes. Now, e-wastes were not even a phenomena until you can say early 2000s, because there was no computer, or computers were very rare, mobile phones were very rare. All the areas related to computers and telecommunication were not in use as much as they are today. And this growth any one of you have seen in your growing years, right? So e-waste was not a thing. So one very important factor of land pollution did not even exist. Another example can be plastics. We knew about the ill effects of plastics, and you have been being asked to use something which is biodegradable for a long time. But the governments, if you talk about whether the Indian government or government at world level, they did not act on plastics as quickly as they should have. But now we have seen governments acting on land pollution, on plastics as well. So all these things have started happening in the last few years, in the last 2 decades, you can say, after 2000s probably. So that's why land pollution became a more important topic in the last few years itself. So if I have to define what is land pollution in very simple terms, what I can write is any physical or chemical change that adversely affects the growth of plants and animals, and directly or indirectly becomes health hazard for humans, right? So any physical or chemical change on land that adversely affects the growth of plants or other organisms or animals, or directly and indirectly can have a health hazard for humans, can be called as land pollution. So various sources which originate from different sources enter either the land, or you can say the agricultural land, and accumulate on the land surface. And after reaching inside the soil, these kind of toxic pollutants affect the biotic components of the soil system in various ways, right? So soil contamination due to these kind of toxicants, they adversely affects the normal growth of plants and animals, and they can even affect all the organisms that are present in the soil. And once they get in contact with the water resources, with the land, with the plants and animals which are grown in these polluting environments, they also affect the human population. So the presence of these pollutants in these soils disturbs the balance of operations of various processes which is going on. For example, if you talk about the nutrient cycles, right? So microbial decomposition gets affected. There is a huge possibility that these microorganisms will get affected. So accumulation of the solid waste on land surface due to unplanned or unscientific disposal, that also creates undesirable or unhygienic conditions. And this is something which is favorable for the growth of disease causing microorganisms. Now, and this becomes one of the reasons for many of the epidemics that happen. So all these kind of things are related to the solid waste in general. So first of all, let's see what are the chief pollutants that we have. So if you have to categorize what are the pollutants and what are the sources of these pollutants, you can have a look here. So first of all, one major pollutant is different kinds of metals. Metals can come from mining ores, from industries, from vehicles, from waste products, from dumps, from sludge. All these can be sources of different metals which can be polluting for the environment. Then you have the pesticides. So majorly it will come from the agricultural fields. Apart from the agricultural fields, it can also come from gardens or parks, etc. Wherever we are growing plants and we are using pesticides to keep them away from the organisms that can affect these plants. Then you have radioisotopes. So radioisotopes can either come from nuclear power plants, or it can come from research laboratories. Then you have other waste. It can be organic waste as well, and these are coming from either households, from municipal works, it is coming from industries, from sludge, from mines, from agriculture, and it can come from hospitals and nursing homes as well. Apart from that, one more aspect that we will discuss is e-waste, which is also a kind of land pollution. We'll also have a brief discussion on biomedical waste. So let's start our discussion with the first kind of pollutant that we have, which is metal. Now various kinds of metals which can originate from different sources, they pollute the land either directly by entering into the food chain or indirectly by contaminating the irrigation facilities that we have. So it can be coming from industrial waste, sewage, sludge, etc., as we discussed. Now, besides soils, these metals can also pollute air and water, and this is something that we have already discussed. Metals which originate from automobiles also pollute the land. And if I give you the examples of metals which pollute, we can take an example of aluminium, then you have cadmium, you have chromium, you have lead, then mercury, can have zinc, nickel can be another pollutant. So all these pollutants you have. You can have selenium, there are others as well. You have copper also, copper can also be a pollutant. So all these pollutants are present in some form or the other. Either it is coming from some industries, it is coming from sludge, it can come from anywhere. It can come from automobiles. So now, especially two of these, lead and mercury, these are especially harmful for us. They enter the bodies of human beings and other organisms through the food chain. Now, the concentration of such metals increases with successive trophic levels, right? Something that we discussed as biomagnification. So, with biomagnification, the concentration of lead, mercury, etc. can increase in the human beings, can increase in other consumers as well, and this starts to accumulate as the trophic level increases. Now, the next kind of pollutant that we have is pesticides. Pesticides, as you all know, that it is something which is used to control pests and pathogens, mainly for the crop plants, right? For crop plants. So they can include fungicides, bactericides, insecticides, all these sides. You have herbicides. So we can have insecticides, herbicides, you can have fungicides. So all these are different examples of the pesticides that we use. It majorly is being used in the agricultural fields, but it is also being used in our parks, in our gardens, in lawns, etc. also. So now, among insecticides, if we have to discuss, we use various kinds of chlorinated hydrocarbons. Like one major example is DDT, one example is aldrin. So we have different kinds of insecticides that are being used. Now, problem with these insecticides is, first of all, they are persistent. Secondly, they are fat soluble. So since they are fat soluble, they accumulate in the fatty tissues of the animals. Then apart from that, they don't break easily. So because of all these issues, it becomes very, very hazardous for the food chain altogether. Now the concentration of these persistent toxic chemicals increases at successive levels, just as we discussed. Now, and that's why what happens is, again, it would lead to something like biomagnification. Now, there also are insecticides which are water soluble and break down easily. But the problem is they are toxic to animals and humans. So even though they break down easily, even though they are problematic for the humans. Now you all know that the modern form of agriculture uses various kinds of pesticides along with the fertilizers. The problem is these pesticides are applied either directly into the soil or the crop plants, and they are applied in different forms, in different ways. So they can be applied on leaves, they can be applied on flowers, they can be applied on fruits. They are obviously being applied directly into the soil. So what happens is, the pesticides which have been applied to all these parts of the plant, they get washed down either by rains or by irrigation water and enter the soil. Now you may say that yes, the insecticides reduce the disease causing pests, but they have an adverse effect on other forms of life. This is what you have to understand. Otherwise, the use of the pesticides we would never have discussed. If I take an example, a certain pesticide can kill the target insect that we want to kill, but these chemicals would also kill a range of useful microorganisms which are in the soil. They can kill the nitrogen fixers, they can kill the phosphate solubilizers, and they can even kill all those kind of microorganisms which are involved in the decomposition of organic matter. So that's why indiscriminate use of pesticides can have adverse effect on the entire ecosystem. They can eliminate some useful kind of insect or plants. So some pesticides, let's say if we talk about DDT, they are even carcinogenic to the humans. Pesticide residues which are present in the body of most of the humans, it is largely because of the sources that we are using, the sources of food that we are using, which were affected by pesticides. So the concentration of pesticides in our body crosses the permissible level or the tolerance level that we have towards these pesticides. So these kind of problems exist with pesticides. Next, let's move on to the next kind of pollutant, that is radioisotopes. Now radioisotopes can be damaging for land in various ways. For example, if you talk about the hot water that comes out of the nuclear plant, that is very damaging, or that can cause thermal pollution to the soil. It can cause, so first of all, hot water can cause thermal pollution to the soil. Now, apart from that, if there is a nuclear fallout, that is the isotopes which are used in the nuclear process, they can cause soil contaminations. Apart from that, the atoms of radioactive isotopes, that is the fissile material that we use, it can be uranium-235, it can be plutonium-239, which are bombarded with the neutrons to split their nuclei, as we discussed in nuclear energy. So some of the other such radioisotopes are also there. For example, strontium-89 and 90, cesium-134. Apart from that, there are some elements which are a part of organism's body. Carbon-14, phosphorus-40, calcium-45, iodine-131. So all these radioisotopes, so just to list it down, you have uranium-235, you have plutonium-239, you can have strontium-89 and 90, then you can have cesium-134. Apart from that, you also have iodine, then you have phosphorus. All these are also radioactive, and they can also have some kind of effect or the other in the organism. You can also include carbon-14 in this, which is the radioactive form of carbon. So now, besides the nuclear power plants and these sources which are present in the organism itself, another major kind of source can be the research laboratories, where these radioisotopes are being used for experimental purpose. Then these radioactive elements which are being released in the air, water or soil, they can have effects on various organisms in different ways. For example, iodine-131, this accumulates in the body, and as the trophic level increases, biomagnification increases, and it can have problems in the human bodies. For example, if you talk about the thyroid problem, this can happen due to iodine-131. Then cesium. So cesium, basically if you talk about the Eskimos in the Arctic region, there we see an accumulation of cesium happening in these people as a result of, again, biomagnification. So what is the route for them? It starts from the soil, right? From the soil, it reaches the lichens. From the lichens, it actually reaches the reindeers, which are a part of the ecosystem there. And from there, they reach the Eskimos. So via this chain, via this food chain, you can say cesium starts to biomagnify in the Eskimos, and then we see different kinds of problems happening in the Eskimos due to cesium. So another thing that needs to be talked about when it comes to radioisotopes is the disposal. Disposal of waste is a very sensitive matter when it comes to radioisotopes. Everyone is aware of the Chernobyl accident. And another problem that is growing globally during, you can say, last decade or so, is the possibility of use of nuclear material by terrorists. So if radioisotopes which are damaging, which can be used as atom bombs, are being used by terrorists, it can have damaging effect to man and environment, to the entire ecosystem. Then apart from this, as we discussed, safe disposal of radioactive elements is a very important problem to be discussed. These wastes are to be disposed of in a way that they are not released into the biosphere, correct? So most of the dangerous uranium may be present in the spent fuel rods itself. They may be present in the fuel rods and not in the reaction core. So that's why these spent fuel rods have to be disposed of properly. Some of the countries have tried to limit the amount of or limit the number of spent fuel rods, right? For example, Germany. In Germany, they use casks. In Germany, they use casks. China actually sends them to a desert storage compound that they have. Apart from that, if you talk about India, Japan, USA, what these countries are doing is that large number of spent fuel rods are being stored in temporary storage facilities which have a security which is comparable to the securities provided to the nuclear power plants. So this is what has been happening, and this is how we are trying to negate the problem of disposal of radioisotopes. So what are the sources of radioisotopes? It can be the nuclear power plant, it can be the experiments that are happening, it can be other radioisotopes also which are not a part of any nuclear reaction but are radioactive. One problem that we face is the safe disposal of waste, and that is another big problem that needs to be seen. Leakage needs to be looked into so that it does not enter the ecosystem which is nearby. Then the next one that we have is solid and liquid waste. So solid and liquid waste can contain, let's say, glass, bottles, crockeries, plastic containers, polythene, different kinds of metals which are being disposed, the organic material which is being thrown away as garbage. So all these are the different kinds of solid and liquid waste that we know of. So these can pile up at public places. They can cause obstruction of daily life. Apart from the normal household junk that we are talking about, it can come from automobiles, it can come from machines, it can come from various parts of machines which are thrown as junk. Then the waste can also come from building material, it can come from dead animals and plants, it can come from a heap of crop residue. So all these can be different kinds of solid and liquid waste that can contribute to land pollution. Now, solid and liquid waste as land pollution is the most important factor that we need to discuss when it comes to land pollution, because India generates most of the waste from municipal and sewage sludge. This obviously is due to the lifestyle that we have, because in the West it is not the biggest, but in India definitely this is the biggest form of land pollution that we have. Treatment system also is not very well maintained in India. This is another problem that we have. So over last several years there has been a significant increase in the generation of municipal waste pollution in India particularly. And particularly if you talk about the urban areas, over last 25 to 30 years the nature of waste has changed, correct, in its composition as well. As we discussed, e-waste did not exist in India. So with changing lifestyles or with changing living standards in India, the composition of solid waste has also changed. Non-biodegradable waste such as metal, plastic, glass, etc., they are being generated in relatively more quantities than the organic waste. So this is another problem that we are facing. So the municipal waste and other solid waste in India, we are going to discuss this again once we come to this particular topic. This here I just wanted you to be introduced with this topic and the fact that India generates most of its waste from municipal wastes. This fact you should remember. Next you have the biomedical waste. So what is biomedical waste? If I just start with a case that happened in India a decade or so back. So in the state of Gujarat, all of a sudden there was a panic, and this panic was due to an outbreak of hepatitis. The total number of people with hepatitis infection, it reached the number 184. The total number of deaths in this 184 were 56. So the uproar started with the spread of this deadly virus, and it triggered a drive to check the unsafe medical practices. So now this led to a discovery of a racket, you can say, that there was a kind of biomedical waste recycling that was happening. More than 50 tons of biomedical waste was discovered from various scraps from the dealers within and across the state. So what they used to do is they used to buy the syringes and needles, they used to buy IV sets, they used to buy empty medical bottles, They even used to buy some of the blood bottles which had crossed the stipulated expiry dates, and then they used to release it back to the hospitals and doctors. So this kind of racket was going on, and this was discovered that hepatitis, one of the major reasons was this as well. So what is biomedical waste? So biomedical waste can comprise of human and animal anatomic waste. It can be coming from needles, it can be syringes, it can be the materials which are used in the healthcare facilities. So all these things which are associated with the healthcare facility can be called as biomedical waste. So any waste which is generated during the diagnosis, treatment or immunization of human beings or animals can be called as biomedical waste. So it also includes the waste generated during research activities, including the production of testing of biologicals. So because these can be made from various organisms of micro or microorganisms and can become a problem for the areas nearby. So common producers of biological waste include hospitals, nursing homes, healthcare units, pathological and research laboratories, blood banks, veterinary institutions, funeral homes, animal slaughterhouses. So all these can produce various kinds of biological waste. So a scientific disposal of biomedical waste through segregation, collection, treatment in an environmentally friendly manner, these can minimize the adverse effect on health workers as well as on the environment. So the hospitals need to have a proper mechanism in place for proper disposal of anything that can become a problem, that can become a biomedical waste. So what are the various methods that we can use for dealing with biomedical waste? It can be installation, deep burial, autoclaving, microwaving, chemical disinfection, schedule and disposal of municipal landfill. All these kind of things can be used to look into the problem of biomedical waste. Next, let's discuss municipal solid waste in detail. So municipal solid waste can either be biodegradable or it can be non-biodegradable, and depending on whether it is biodegradable or non-biodegradable, we have different ways in which we act against it. So for example, if you have a biodegradable waste, we would use the method of composting. So compost all biodegradable waste and turn it into useful fertilizer. Composters are now available for households, for communities, and even for municipal areas. So this can be the way of looking into the menace of biodegradable waste. But biodegradable waste is not as big a menace as non-biodegradable waste is. And the solution to biodegradable waste is not only in carrying out a process which does not take much of time. Problem is that waste have to be used in a judicious manner, but a bigger problem that we have is non-biodegradable waste, and for a very simple reason that it cannot be degraded as quickly as biodegradable waste can be. So that's why we have to use various methods which can help us to reduce the amounts of the things that are causing non-biodegradable waste, that are leading to non-biodegradable waste. So these are some of the ways in which we can try and reduce the amount of non-biodegradable waste. Mainly we talk about 4 R's here. What are these 4 R's? First is refuse, then you have recycle, then you have reuse, and then you have reduce. Right? So these are the 4 R's of looking into the problem of non-biodegradable waste. So let's start with the first one, that is refuse. And we'll also, when we talk about recycle, we'll also talk about something called as upcycle. Upcycling is a procedure or a process that is a new concept, so we'll have a discussion on that. So first, starting with refuse. What is refuse? Refuse to buy the things that you do not really need. Now, so talking philosophically, there are many things that you want and you don't need. So we should not go for the items which we don't need. But it's very difficult for someone to become so ideal and do this. But yes, this is something we have to try and incorporate into our lives. Then refuse the plastic carry bags offered by the shops. Take your own cotton bags to the market and grocery store. Minimize buying heavily packaged items. Then Avoid buying dangerous substances such as mosquito repellents, insect sprays, chemical cleaners, detergents, etc. Use as far as possible natural or organic alternatives. So this is the first part of the 4 R's, that is refuse. Then the next that we have is reduce. What reduce what? First of all, buy things only when you really need them. Extend the life of your gadgets by upgrading them if possible. So nowadays we have a habit. There's a new phone in the market. I'll go and buy it. There's a new model of some electronic gadget in the market. I'll go and buy it because I can, not because I need it. So there's a difference here. So you do not need to upgrade your phone every year or every 6 months. You may need it only after the previous phone that you had has stopped working. As soon as we see a new model, we go for it. That shouldn't happen. So that's why extend the life of your gadgets and try to upgrade them if possible. Ensure effective preventive maintenance, proper handling and timely repairs. So these can be some ways of reducing the non-biodegradable waste. Then you have reuse. What is reuse? Reuse every possible item at home, from paper to plastic bags, cards, envelopes, wood, etc. Buy food items in reusable or refillable containers. Buy rechargeable batteries if possible. Donate old clothes, books, electronics, etc. to NGOs for refurbishing and reuse. Then the next one that we have is recycle. So do not throw away e-waste or other toxic material like batteries, thermometers or insecticides into the garbage. Take them back into the manufacturer or to the responsible recyclers. Buy recycled products. Now an upgraded way of recycling an item can be upcycle. What do we mean by upcycle? We mean that we reuse the material in such a way as to create a product of higher quality or value than the original into something useful, often something beautiful. For example, your own torn clothes. They can be upcycled into cushion covers. Tin cans can be used as pen holders. Papers can be turned into decorative material like flowers, etc. So all these kind of things could be called as upcycling. So basically what is the difference? Recycling takes the consumer material. It can be plastics, glass, metals, etc. It breaks it down into their basic material, the base material, and then from there it is made into or remade into a new consumer product. But most of the times this new product will often be of a lesser quality. So since it is of a lesser quality, upcycling is actually a better way of going with it. So when we upcycle a material, we are not breaking down the material. We may be refashioning it, but it is still made of the same material as when we started. So that's why there is a difference between recycling and upcycling. The next kind of solid waste that we have is e-waste. Now what is e-waste? So e-waste, or in other words electronic waste, consists of discarded television sets, cell phones, computers, iPods, other electronic devices, right? So it has become the fastest growing solid waste problem in the world. So problem is, if I give you an example of United States, more than 160 million cell phones are being discarded every year. Approximately more than 70 million TV sets. Not only this, more than 50 million computer sets. And apart from that, you have iPods and other electronic devices which are being discarded. So now what happens is most of these e-waste, they also end up in landfills. What are landfills and what are the problems of landfills? We'll just come to it. Now, more than 80% of the components which are used in these, which are a part of these e-waste, they are the ones which can be recycled or reused. These can be something like aluminium, copper, let's say platinum, silver, even gold at times. Now e-waste is a source of hazardous pollutant, like for example PVCs, you have brominated flame retardant, you have lead, you have mercury. All these are the things which can accumulate, or it can contaminate the air, it can contaminate the surface water, groundwater, soil, it can cause serious health problems. So It has also caused even the deaths of the people who are working as e-waste workers. So the problem also is that there is a transfer of hazardous waste from the developed countries to the developing countries, which actually is banned. There was something called as Basel Convention, and this Basel Convention has banned the transport of these e-waste from the developed countries to the developing countries like India or China. Now the problem is much of the e-waste is not officially classified as hazardous waste, and that's why it is illegally smuggled to countries like India and China. Now another problem are the industries which make the products which are generating these e-wastes, right? For example, if you talk about the mobile phone companies, they are running on obsoleteness. If iPhone 7 is not obsolete, you would not buy iPhone 10. You would still keep on buying iPhone 7. So the entire problem of consumerism is causing the problem of e-waste, right? So, and as long as the older product is not obsolete, the newer product will not be bought. So the older models are discarded as junk even when they are in working conditions, because you have a new product now. And all this has resulted in e-waste becoming one of the fastest growing waste streams globally. So this is the problem of e-waste. Most of it is coming from the computer parts, from the cell phone parts, etc. Then if we talk about the problem that we are facing in India, before that, if we just discuss what happened globally, in 1990, the total number of e-waste that we had was approximately 19.5 million tons. It was 19.5 million tons. In 2010, it had reached 57.5 million tons. In 2015, approximately 75 million tons. So this is 1990, this is 2010, this is 2015. So such has been the growth of e-waste in the world. Now in India, most of the e-waste end in informal or unorganized sector. In addition to local waste, there is also waste imported from the industrialized country. As we discussed that, although Basel Convention had stopped this transfer, but since it is not even being classified as an e-waste, it just runs from those countries to country like India. So in Delhi and other towns, a large number of poor people, including women and small children, break open these gadgets to recover valuable parts and materials. With no prospective equipment and poor working conditions, these workers are exposed to toxic chemicals, suffer physical injuries, and chronic ailments like asthma, skin and eye diseases, and even or life-threatening diseases. So this is the problem that we are facing in India. And if you look at this particular diagram, you would understand that most of the e-waste that India generates, 70% of it is only computer equipment. Rest you have 12% telecommunication equipment, 8% electrical equipment, 7% medical equipment, and 3% other equipment. So in totality, 1,47,000 tons per annum was the waste being generated in 2005. In 2016, it was 1.85 million tons per annum, and the projection that we have for 2018 is 3 million tons per annum. So this has been the rise of e-waste in India. Now, responding to this problem of e-waste, the government of India introduced the e-waste management and handling rules in 2012 or 2011. Management handling rules. So this was introduced in 2011, then in 2012 it came into force, and in 2016 we did some amendments, we brought in a new rule as well. So this is something that has been happening. Consumers now have been made responsible for proper disposal of e-waste that is being generated by them, and they are supposed to hand these gadgets to authorized collectors or dismantlers or recyclers. Now they can also give it to the companies from where they had bought the item. The producers are required to ensure collection and recycling of waste, and they are supposed to set up a take back system across the country which would be able to handle the e-waste. Now, although this is a welcome step that these rules have come into picture, problem is that many of the environmentalists feel that these rules are very weak and the implementation has not been proper because proper collection systems have not been put in place. There is no incentive either for the consumer to deliver the waste to the collectors or for the small recyclers and scrap merchants to change their ways with respect to e-waste. Now let us discuss how is municipal waste being handled in India. So first of all, it is very difficult to estimate the amount of municipal waste that is produced in Indian cities. According to one study that happened in 2012, the daily per capita generation of municipal solid waste in India ranged from 200 grams to 870 grams. And this depends on the region, the lifestyle of the region, the size of the city, everything. Per capita waste generated by Indians increased by about 1.3% per annum. Now, the total solid waste which is generated in India annually is about 62 million tons, and this is increasing. Now, out of this, recyclable content is said to be approximately 13 to 20%, and the water collection efficiency releases varies from 50 to 90%. Now, it is also clear that the amount of solid waste which is being generated, that is growing faster than the population growth of India. Just to give you an example of Mumbai, during the period of 1981 to 1991, the population of Mumbai had grown from 8.2 to 12.3 million, right? And basically you can say there was a 49% growth in the population of Mumbai. In the same period, the amount of waste that is being generated, the amount of municipal waste that was generated in Mumbai, that grew from 3200 tons to 5355 tons in the same period. That is, you can say, a growth of 67%. So growth of population 49%, growth of solid municipal waste generation 67%. Current estimate is that Mumbai generates more than 7,000 tons of waste every year, and this is expected to grow to 10,000 tons by 2025. Not only this, if I move out of Mumbai, 70% of Indian cities do not have adequate waste transport facilities. Out of the total municipal waste that is collected, on an average, you can say 95% is dumped on land and rest 5% is composted. So as a result, the streets are full of garbage, the drains are choked, the urban canals that you have, they are filled with filth. The garbage that is transported in polluting old trucks, they are dumped anywhere. They are dumped in the low-lying sites, in the areas which are outskirts of the cities. The choice of sites is not actually a matter of availability. It is more than that, it is a matter of suitability, right? So in most of the Indian cities, the solid waste actually lie unattended. They lie on the dump sites where they attract birds, they attract rodents, they attract insects and other organisms. Now as the waste decays, obviously it releases a lot of odor and it leads to a lot of airborne pollutants as well, airborne pathogens also. So further, the practice of burning of the waste, that also creates a toxic environment. The smog situation in Delhi is an example in front of our eyes. So all this is also a problem. The key issue also, I would say, is the lack of segregation at source. This can be biodegradable substance, it can be a non-biodegradable substance. So segregation at source is also very important. So the problem is that the citizens do not cooperate and the officials are not ready to implement their own orders. So this is leading to another set of problems of generation of municipal waste. The villagers who are living near landfills, they keep protesting every now and then, and even they try to stop the dumping of waste in the areas where they live, but they are not being heard of. Now as the cities expand, the corporations have to go farther and farther, right, to look at the sites which will be used for landfills. and the problems of landfills is something that will just come to. So whether you talk about the citizens, you talk about the politicians, you talk about the bureaucracy, all these are not willing enough to solve the problem that we are facing, and this is making the problem much more severe for the municipalities. So even for the municipal corporations, it is very difficult to keep our cities clean right now. Another dangerous practice that we see is the disposal of biomedical waste, which is being dumped along with municipal waste. That shouldn't happen, because the biomedical waste could turn the entire yard infectious. Not only this, the biomedical waste also contains sharp objects such as needles. This can injure or infect the rag pickers and the municipal workers who are working there. Not only this, now it's not that we don't have a thing in place. For example, biomedical waste management and handling rules, they were made back in 1998, but the hospitals are not following them. And since the hospitals are not following them, the rules are there, but they are not being implemented properly. Even if they are being implemented, it is not being followed properly. So it's not only the government of the country who has to work against these kind of issues, it's also the citizens who have to work, and that's not happening. And since that's not happening, the menace of solid waste is not going away. Now, last few years there have been some systems that are being made. For example, we have a system called zero waste systems, which are being attempted in some cities. Sanitary landfills are also coming up, for example near Delhi. Back in 2014, the government of India also launched Swachh Bharat Abhiyan, and no doubt it is a groundbreaking initiative by the government. But it's not only on the government, the onus is not only on the government, but it's also on the citizens of the country. So everyone has to work in unison if you want a proper output out of programs which are launched like this by the government of India. Not only this, there have been other programs. For example, if you talk about the smart cities programs, so smart cities also will be looking into the management of waste. You also have a program by the government called Amrut. This is also a program which will be helpful, but what matters is how well these all programs are being implemented. That also matters a lot if you want a proper result out of all these areas, all these programs that are being launched by the government. Now, one thing that I want to discuss in this lecture is the problems related to the landfills in India. Now, we all know that India is growing at a fast pace. Urban India faces a huge problem, that is maintaining the load of solid waste in these areas. Now, the population of India is growing at 3 to 3.5% annually. Urban waste is growing at 5% annually. Problem is, our cities do not have the space to dispose it. And going forward, the challenge is going to be tougher. In 2014, there was a report of the Planning Commission at that point of time, and which was headed by Kasturi Rangan, K. Kasturi Rangan. Now, this report said that 62 metric tons of solid waste was being generated in India every year. And based on the calculations, an average of 450 grams is the per capita for India's urban population. According to another report which was published by Central Pollution Control Board in 2016, approximately 23% of all the waste that is produced in India is processed. 23%. It is taken to landfills, it is disposed using other technologies, etc. But most of it is taken to landfills. Now, the issue with the data on waste generation in India is that the figures are extrapolated. So, the values which are being taken in the reports, they are extrapolations. Most of these reports actually rely on the data that was produced by the Central Pollution Control Board with the assistance of National Environmental Engineering Research Institute, and this was in 2004-2005. So, this research was conducted in 59 cities at that time, 35 metro cities and 24 state capitals. Now, this was the last report that had real-time data on waste generation in this country. So, this makes the estimate of solid waste generation in the country pretty much, you can say, an estimate, which is probably a guesswork most probably. Now, in 2017, there was something called as Swachh Sarvekshan ranking, right? If you remember this, Swachh Sarvekshan ranking, back in May 2017. So it ranked 434 cities based on the cleanliness and sanitation. Problem is, this ranking not only promoted the cities with poor waste management practices, but more important than that, the fact is that the cities with good practices featured very low in the annual rankings. So, if you take an example of Indore, Indore, according to the ranking, was the cleanest city in the country. And this is despite the fact that there is an absence of solid waste processing facility for solid waste segregation at source, as we discussed. So, Indore is not the only exception. Most of the top 50 cities that featured in these rankings share a similar story. Now, the maximum weightage in these rankings actually was given to, you can say, procedure for collection and transportation of the solid waste. But if you talk about the parameters which were taken, these parameters actually favor a centralized model where the emphasis is on treating the waste away from source. So the parameters favor treatment of source wastes away from source. So this is a big issue that we have with this ranking that was given up. Now, not only this, according to Central Pollution Control Board, an estimate is that over 90% of Indian cities with functional collection system dispose of their waste in landfills. And these landfills are not made according to the stipulated sanitary standards. Back in 2008, Central Pollution Control Board's monitoring of cities found that 24 out of 59 cities were making use of landfills covering 1900 acres of land. Another 17 cities had planned to create landfills, and since the landfill was becoming scarce with the city limits, the municipalities were looking for regional sites to dump all the waste. Then in 2009, and a paper by the Department of Economic Affairs, it estimated that already urban India was producing 18,000 metric tons of waste every day. And the projection was that by 2047, India would be producing 260 metric tons of solid waste annually, which would need an area of 1400 square kilometers of landfill. Just imagine how big is 1400 square kilometers of landfill. This is basically an area equal to Kolkata, Mumbai and Chennai put together. So now another problem that we have in India is that despite the rules, the landfills are incentivized in India. Currently all the contractors in India, they are incentivized by the state governments to bring larger quantities of waste to the dump sites. The incentive is on bringing larger quantities of wastes to dump sites. Problem is that contracts are based on the payments of the tipping fee. That is, more the waste that is brought to these dump sites, the higher would be the tipping fee. So the cost of the land and its unavailability is something which is not even accounted for. And that's why the problem is that landfill, you have to understand, is not the solution. Take Delhi for example. If you look at this particular picture, the Ghazipur landfill in Delhi is now going to match the height of Qutub Minar. And this is a serious issue. The allowed height of landfill was just 20 to 25 meters. In 2017, it reached 60 meters. In 2018, according to government reports, it has reached 65 meters. So this is the height of the Ghazipur landfill. Not only this, Ghazipur landfill in 2017 had met with an accident, that a part of this landfill had caved in, and as it caved in, it took the life of 2 people who were in the vicinity of this landfill. and after that there was an uproar, there was a hangama that happened. But what happened is it was closed for a few days, but the normal operations started again. So, and as of 2018, it has reached 65 meters, which is horrible. Now, if we just talk about this Gazipur landfill, 29 acres of area is being used. It became operational in 1984. In 2002, it reached its saturation, but still nothing has happened after that. And the current status is that the dumping continues. Supreme Court has also given some observations on it. First, in March 2018, the days are not far when the Gazipur landfill site will be as high as Qutub Minar, and a red beacon will have to be used to ward off aircraft. Then we keep on passing orders, but solid waste management rules are not implemented. India will go down under garbage one day. And not only this, in August 2018, there was a proposal to build a landfill near Sonia Vihar area, and then the Supreme Court had given an observation that why shouldn't the garbage be dumped in front of Lieutenant Governor's office instead of harassing common people. So despite all these things happening, all these observations being given by the Supreme Court, nothing is changing. If you just have a look at this particular picture, this belongs to the landfill in Delhi. And if you just want to have a look at what is the scale of the landfill that we are talking about, you can just have a look at this particular video presentation, which will run here for approximately 2 minutes. You can just have a look at it. So this video was made by Hindustan Times in 2017 as a part of their presentation when the accident happened and the landfill in Delhi killed 2 people. Now this brings us to the question that we have, that is landfill the solution? Now in many countries this question has been answered by reversing the system. A fee is being paid not for the collection and transport, but for the disposal of waste. Take an example of Sweden, or even in US for instance, there is a high gate fee levied by the landfills to dispose of waste. Sweden also charges landfill tax. So when you have a high gate fee, obviously the municipality does not want to dump waste in these landfills. So in Sweden, an average landfill charge was approximately 212 US dollars in 2013. So that's why to minimize the use, the authorities have to try and impose a landfill tax. and try to build sanitary landfills for disposing of residual waste so that there is a lesser quantity of land pollution happening in India. Ensuring a zero landfill future has to be the aim of a reinvented waste management system. The Solid Waste Management Rules 2016, Management Rule of 2016, this accepts the fact that landfill should only be used for residual waste, which is non-usable, non-recyclable, non-biodegradable, non-combustible, non-reactive, these kind of waste. And this particular rule also talks about the fact that every effort will be made to recycle or reuse the rejects to achieve the desired objective of zero waste to landfill. Now, this is a very important departure from the previous policies, which emphasized on the need for sanitary landfill. Also, this particular rule highlighted segregation at source. The rules have also prescribed that the local bodies should try and impose user fee for waste generation and possibly levy spot fines for the people who litter or who fail to comply with the provisions of the rule. So, these were some of the parts of Solid Waste Management Rule of 2016. So with that discussion on the municipal waste in India, we come to an end to this particular chapter. Please remember that this chapter is going to be more important for you from mains point of view rather than from prelims point of view, because most of the things that we are discussing here are not one-liners but are some things which can be asked in your GS paper 3 in the mains exam. So with this, I'll end the chapter here, but there are three things that I want you to remember. First of all, e-waste management rules of 2016, then biomedical waste management rules of 2016, and finally plastic waste management rules of 2016. So the salient features of these three rules of Government of India, I would suggest that you should know this. What I'm going to do is that I am making a document on these three, and this will be available on your student portal. So please go to the student portal and just read the salient features of these three. Remember the facts that are present in these rules, so that if at all you get a question on solid waste management, you should be able to answer them easily, right? So with that, I'll end this chapter here.